Alright, we want to find the tangent of 67.5. We know that 67.5 degrees is in quadrant 1, therefore the tangent is going to be positive. Now the first thing you notice about finding tangent using half angle is there are 3 different identities. And why would you use one over the other? Well, first of all, this first one and second one, both of them require you to know the sine and the cosine of the whole angle, which that shouldn't be too hard. And the second one requires you just to know the cosine. There might be times when you would want to use one over the other, but more likely that would be when you are proving identities. For just finding the exact value, it really doesn't make much difference. You can pick one over the other. So this example I'm going to work with you, the first one and the second one, the algebra and the mathematics or the arithmetic is quite a bit the same, but the third one it gets a little complex, and it's kind of just because of what the cosine value is. Alright, so let's proceed here. So the half angle is 67.5, so that means the whole angle, when we double that, we get 135. Okay. So the half angle is in quadrant 1, so it's positive. So let's first use this first one right here. We're going to use A. So that's going to be the sine of 135 over 1 plus the cosine of 135. Let me work down. So that's going to be square root of 2 over 2 all over 1 plus a negative square root of 2 over 2. So square root of 2 over 2. So I can make this 2 over 2 minus square root of 2 over 2. Now let's move up here. So the numerator square root of 2 over 2. Denominator 2 minus the square root of 2 all over 2. So you've done enough of these by now that you should notice when your denominators in the numerator and the denominator are the same, when you take the top one, fraction, and multiply it by the reciprocal of the bottom, if your denominators are the same, they disappear. So you can kind of just shortcut that to then be square root of 2 over 2 minus square root of 2. Now we're going to put parentheses around the bottom, and we're going to multiply by the conjugate. So the numerator becomes 2 times the square root of 2 plus 2. The denominator becomes 4 minus 2. And let's move our work up here. So 2 times the square root of 2 plus 2 all over 2. There's a 2 in every term, so I can reduce by 2. So that becomes square root of 2 plus 1. And it's positive because it's in quadrant 1. Alright, so that's using the first one. Using the second one, you'll get something similar. And I'm going to set up the third one for you, so you can take a look at that. Same problem. But now we're going to use the tangent of 67.5, and now we're going to use this one, square root of 1 minus cosine of 135 all over 1 minus cosine, one of them is plus, this one's plus, cosine of 135. Alright. So square root of, we got 1 minus negative square root of 2 over 2 all over 1 plus, this is a negative square root of 2 over 2. And let's see, that becomes a 2 over 2 plus square root of 2 over 2 all over 2 over 2 minus square root of 2 over 2. This radical's longer here. And so that becomes 2 plus the square root of 2 all over 2 all over 2 minus the square root of 2. I'm running out of room here, all over 2. Moving that up here. Denominators in the numerator and the denominator are the same, so I can get rid of that. So 2 plus the square root of 2 all over 2 minus the square root of 2. Alright, so first of all, let me caution you, it looks like there's a 2 in every term. There's not a 2 in every term. There's a 2 here and a 2 here, but this is a square root of 2 and this is a square root of 2. So you can't just cancel 2's. You cannot cancel 2's. You have to have the same value in every term, and you do not have that. Alright, so what we do have are radicals under radicals. So I'm going to multiply under the radical by the conjugate. All of this is under the radicals still. So the numerator we get 4, and then we have plus 2 times the square root of 2, plus 2 times the square root of 2, plus 2. Denominator, we have 4 minus 2. So let's see, the numerator 4 plus 2 is 6, and then plus, let's see, 2 plus 2 is 4, so 4 square roots of 2 all over 2. Okay, now I've got a 2 in every term here, so let's reduce. 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 6 3 times, and I'm going to just move sideways here because I'm running out of room. So my denominator's disappeared, so I have 3 plus 2 times the square root of 2. Okay, so there's our answer using the tangent, the third version of the tangent. And some of you might say, hey, that's not what we got when we did the other example. When we got the other example, we had square root of 2 plus 1. So what I'd like you to do with your calculator, you should just kind of do this every time, is when you are all done solving these problems, you take your calculator, first of all, make sure you're in degree mode, and then you actually type in tangent of 67.5, and then leave that right in your calculator, and then type in this radical and see it's the same. And then for this problem, go ahead and type this radical in, and you'll prove to yourself that it is indeed the same thing also. So 2 different forms of the same exact value answer for tangent of 67.5.